The Enhanced Ground Proximity Warning System, or EGPWS, provides alerts and warnings in addition to those provided by the original GPWS. While the original GPWS alerts and warnings remain available, more descriptive oral and visual alerts are available with the installation of the EGPWS. EGPWS visual alerts are provided by painting density dot patterns of green, amber, or red on the HSI, where each color and the density identifies the threat level of the terrain. Other visual alerts consist of display messages on the HSI or ND and illuminated lights. When the terrain switch is pressed, continuous terrain display is available. Terrain within 2,000 feet of airplane barometric altitude can display on the HSI or ND. Terrain display is available in any range for the HSI modes of VOR, approach, map, and center map. The criteria for color and density dot is shown on this frame. It is not necessary for you to memorize these values, only to understand the importance of the colors and density. Both terrain data and weather radar cannot display simultaneously on one HSI. Therefore, one pilot may display the weather, while the other pilot displays the terrain. However, when weather is displayed, it will be replaced by a pop-up terrain display if a terrain conflict should occur. When one pilot is displaying weather and the other is displaying terrain, each display updates on alternate sweeps. Although the terrain display appears to sweep across the HSI, it does not indicate a scan system, but merely the method of painting the display across the screen as the data is processed. Oral and pop-up visual alerts warnings are available regardless of the position of the terrain switch. EGPWS oral alerts are very descriptive. There is one for a caution alert and another for a warning alert. The EGPWS can be considered a predictive system as compared to the original GPWS, which functions as a reactive system. The original GPWS alerts remain available except for the oral whoop whoop of modes 1 and 2, which have been replaced by new EGPWS oral alerts that are more descriptive. Predictive warnings of close proximity to terrain are now available because of the aircraft position determination of the onboard GPS in conjunction with software data that includes a worldwide terrain and runway database. There are two new modes that are available with EGPWS. They are Terrain Awareness Alerting and Terrain Clearance Floor Alerting. Terrain Awareness is always available, while Terrain Clearance Floor Alert is operational only when in close proximity to an airport. So, how does it all work? The GPS constantly determines the position of your aircraft. That position is cross-referenced to the onboard terrain database and the even more precise runway database. By comparing the position of terrain with the aircraft position, the EGPWS is able to provide terrain alerting for en route operations and even more precise terrain alerting when in the vicinity of an airport. Similar to the TCAS, the alerts from the EGPWS are based upon estimated time to impact. Because of the Look Ahead feature of the EGPWS, you can expect these predictive terrain awareness alerts to be issued in advance of the original GPWS Reactive Mode 2 alert. In order to prevent unwanted alerts, the EGPWS automatically adjusts the Look Ahead values based upon ground speed, turn rate, and proximity to an airport. You have learned that the EGPWS provides both a terrain awareness alerting and terrain clearance floor alerting. Let's look closer at each of these alerts. Terrain Awareness Alerting. The Terrain Awareness Alerting is operational at all times to warn of flight towards steep rising terrain. Based upon our earlier operating description, you should know that this system is able to predict flight toward a sheer cliff. Terrain awareness alerts are provided as both cautions and warnings. These look-ahead alerts are prioritized on the danger level and the required reaction time of the flight crew. Caution alert. Terrain caution alerts are provided when the airplane enters the terrain caution envelope, which is approximately 40 to 60 seconds prior to an estimated terrain impact. A caution alert consists of oral and amber visual alerts. Before a terrain caution occurs, with the terrain switch on, the terrain will display on the HSI as a density dot pattern. The higher the threat level, the higher the density dot pattern. When the caution alert occurs, the threat area displays as a solid color rather than dots. This display will pop up even if the terrain switch is not selected on for display. The oral alert of Caution Terrain is repeated every 7 seconds until clear of the caution envelope. Terrain that is depicted at or above the threat altitude is displayed on the HSI as solid amber, while terrain that is depicted at 2,000 feet above the aircraft and higher displays as solid red. The amber terrain message displays on the HSI. Finally, a caution alert will also cause the ground proximity light to illuminate during the event. A warning alert is provided when the airplane enters the terrain warning envelope, which is approximately 20 to 30 seconds prior to an estimated terrain impact. A warning alert consists of oral and red visual alerts. Before a terrain warning occurs with the terrain switch on, the terrain will display on the HSI as a density dot pattern. The higher the threat level, the higher the density dot pattern. When the warning alert occurs, the threat area displays as solid red. This display will pop up even if the terrain switch is not selected on for display. The oral alert of Terrain, pull up, pull up, pull up is repeated continuously until clear of the warning envelope. Terrain is depicted at or above the threat altitude in solid red, along with a red terrain message. The master warning lights illuminate, and a pull-up message displays on the ADI during the warning. That pretty much covers the description of the terrain awareness alerts. Now let's discuss the terrain clearance floor alerting that provides enhanced alerting for areas on approach to a runway. Terrain clearance floor. Terrain clearance floor alerts are installed to prevent landing short of the runway. The more precise runway database includes data for the approach area into runways longer than 3,500 feet. The EGPWS creates a computerized floor on approach to these runways, for which the aircraft should not fly below during the descent for landing. The floor starts backwards from the approach end of the runway and extends up at 1 degree per mile until it is 400 feet above the local terrain at 4 miles from the end of the runway. The floor remains at 400 feet above the local terrain until a distance of 12 nautical miles from the runway, where it rises again at 1 degree until it is 700 feet above the local terrain at 15 nautical miles from the end of the runway. Okay, we've built the computerized terrain clearance floor. Now what protection does it provide? If the aircraft penetrates this floor, the ground proximity light illuminates and the oral alert, too low terrain sounds. You should know the terrain clearance floor alerts are designed to predict terrain conflicts that are approximately 1/8 of a nautical mile on either side of the airplane and projects out 3 degrees from both sides of the airplane. Note, man-made obstacles are not included in the terrain database. The EGPWS will therefore not provide early warning or alert for man-made obstructions. This completes the description of terrain clearance floor alerting. Let's finish with a review of some operational issues. First, pilots are authorized to deviate from their current ATC clearance to the extent necessary to comply with an enhanced GPWS alert. Inform ATC as soon as possible of the situation. All EGPWS alerts can be inhibited by pushing the terrain override switch to the override position. In this situation, the original GPWS modes remain operational. There are certain times or conditions when flight crews may place the EGPWS in override. These conditions and when to return to normal operations are specified in your flight manual. See your flight manual for company procedures to use in the event of a caution alert, warning alert, or terrain clearance flooring alert. Never navigate by use of the terrain display. The terrain display is intended to serve as a situational awareness tool only and may not provide the accuracy fidelity on which to solely base terrain avoidance maneuvering decisions. Therefore, the terrain display must not be used for navigation or escape guidance in response to terrain warnings. If there is no terrain data in the database for a particular area, terrain alerting is not available for that area. These areas are highlighted on the display using medium-density magenta dots. Finally, the terrain alerts are inhibited by an actual wind shear warning when the aircraft is actually in a wind shear condition.
GL. Below 1,450 feet AGL, TCAS will not deliver increased descent RAs. Below 1,000 feet, TCAS will not deliver descend RAs. Below 500 feet AGL, TCAS will not deliver RAs of any nature. TCAS will not provide any audio warnings when your altitude is below 400 feet AGL. TCAS is programmed with your aircraft's normal climbability and service ceiling. It can only give a climb RA if a climb to higher altitude is possible. However, TCAS is not programmed with situations that reduce aircraft performance. Therefore, if you're operating with an engine out or other performance restriction, TCAS will provide normal RAs without regard to the current aircraft performance restrictions.
To operate normally, the transponder must be selected to TARA mode, the electrical systems must be powered, and the aircraft must be at altitudes other than those where TCAS inhibits are active. Review your company's policies regarding use of TCAS and operational guidelines. We will use typical industry practices here for training purposes. When abnormal conditions exist, or runway conditions require close proximity traffic, it may be permissible to select the TA mode to eliminate nuisance warnings. However, placing the system off is never recommended. See your company documentation for specific information.
TA may be selected During takeoff towards known nearby traffic which is in positive visual contact and which would cause an unwarranted RA, reselect TARA as soon as possible. During parallel approaches, when the other aircraft has been positively identified VMC or by the controller IMC. In visual conditions when flying in known close proximity to other aircraft. During emergencies and in-flight failures that severely limit the aircraft performance or control to the point that ability to respond to an RA is in doubt, and in response to specific company guidance regarding areas or operations identified as having a verified and significant potential for unwarranted RAs. The system priorities are shown on this frame. If simultaneous alerts are given from the higher priority systems, the TCAS operates in the TA mode and the RAVSI flag, RA off, is displayed. The see and avoid concept remains the highest priority in collision avoidance. When an RA is delivered, it has priority over an ATC vertical clearance. Air traffic control should never tell a crew to ignore a TCAS RA. If you use the see and avoid concept to override an RA, you must ensure that the TCAS intruder is in fact the same aircraft that you have visually identified.
TCAS 2. The Traffic Collision and Avoidance System, or TCAS 2, provides the flight crew with a tool to assist in the avoidance of other aircraft. TCAS 2 provides vertical separation advisories for close proximity aircraft. It is important to note that TCAS provides only vertical advisories and does not provide advisories for horizontal separation. TCAS provides oral and visual advisories to the flight crew. Oral advisories are delivered through the cockpit speakers, while visual advisories are displayed on the EADI. In addition, TCAS displays the relative position of transponder-equipped traffic as symbols on the EHSI. TCAS operates on the principle of delivered and received transponder signals. Your aircraft emits signals and receives signals sent from other transponder-equipped aircraft. The TCAS receives signals from other aircraft transponders within a range of approximately 40 nautical miles. TCAS signals are picked up by your TCAS antennae and are sent to the TCAS processor. The TCAS processor computes the relative position of the other traffic, paints symbols, and when appropriate, issues vertical advisories. If the intruder aircraft is also TCAS equipped, your TCAS will coordinate advisories with the other aircraft's TCAS to ensure that both aircraft are guided away from each other. The processor is programmed with your aircraft's normal performance limits. It will not command a maneuver outside normal aircraft capability. It is not aware of abnormal conditions that may restrict normal aircraft performance, such as an engine failure. The Mode S transponder receives and sends signals through the antennae. In addition to range, bearing, and altitude, a signal is sent that identifies your aircraft type. The transponder control panel holds the TCAS controls. The transponder can be operated without TCAS, but this isn't allowed for normal conditions. The EADI is the primary TCAS guidance instrument. The TCAS system provides a protective sphere around your aircraft that consists of a surveillance boundary. The boundary range is approximately 40 nautical miles in front of the aircraft and 9,000 feet above and below. TCAS advisories are generated based upon the concept of closest point of approach, or CPA. The CPA is that point at which another aircraft is calculated by TCAS to penetrate a safe boundary around your aircraft. The safety boundary is computed as a function of time. Therefore, traffic approaching head-on with a fast rate of closure will normally generate a warning from a greater distance than traffic that is approaching from the rear. When an intruder aircraft is predicted to penetrate the CPA from any direction, TCAS will activate either a traffic advisory or a resolution advisory. A traffic advisory, or TA, is delivered when intruder aircraft are between 35 and 45 seconds from the closest point of approach of your aircraft. A traffic advisory is announced by cockpit speakers and displayed as a small yellow circle to indicate the relative position of the intruder. When a TA is delivered, the flying pilot should attempt to visually locate the intruder. No evasive action based on TCAS information is authorized when a TA is received. When a TA occurs, the flight crew should clear the area in case a subsequent evasive maneuver is required. Remember, pilots are not to maneuver their aircraft based on a TA.
A resolution advisory, RA, is delivered when intruder aircraft are between 20 to 30 seconds from the closest point of approach to your aircraft.
An RA always delivers a specific oral and visual command. When an RA occurs, the flight crew is to maneuver the aircraft in the appropriate vertical direction within 5 seconds. The same response rate is used to respond to an RA as would normally be used to respond to an ATC call to climb or descend immediately. The aircraft climb or descent in response to an RA should be with approximately 0.25 G-force. If an RA is delivered that is a reversal or an increase to a previous RA, the pilot must respond within 2.5 seconds with approximately 0.35 G-force. Pilots must never respond opposite to an RA command. When a TCAS event occurs, the pilot should notify ATC that a response to a TCAS RA was necessary. As soon as the RA is over, the pilot should return to the ATC clearance altitude or as directed by ATC. This is a list of all TCAS RA verbal advisories. Read the description of each advisory. The transponder control panel is used to control the Mode S transponder, the predictive wind shear system, and the TCAS system. Four symbols and 3 different color conventions, white, yellow, and red, are used to represent different threat levels. Different display modes allow the symbols to display alone without weather, or as overlays on the weather display. In addition, a pop-up mode is available that allows TCAS symbols to display only when there is a TCAS threat. The TCAS speaker provides vocal commands to confirm the guidance during a resolution advisory. There are many verbal guidance phrases that can be delivered for various types of resolution advisories. During a traffic advisory, the speaker will provide the announcement of traffic, traffic. You have learned that your aircraft TCAS system sends signals to other aircraft through the new Mode S transponder. Other TCAS-equipped aircraft can therefore coordinate evasive maneuvers with your TCAS aircraft. Aircraft equipped with a Mode C transponder do not have TCAS. However, the Mode C transponders emit the necessary range, bearing, and altitude signals to your TCAS Mode S transponder. Your TCAS can provide advisories to fly clear of Mode C equipped aircraft. However, the Mode C aircraft receives no guidance as it is not TCAS equipped. If the other aircraft is equipped with a Mode A transponder, it cannot send altitude signals to your TCAS, but will send range and bearing data. TCAS assumes these aircraft are at your altitude. TCAS can provide traffic advisories for these aircraft, but will not provide resolution advisories. This type of traffic is referred to as non-altitude reporting traffic. Aircraft that have no operating transponder are invisible to your TCAS system. This includes those aircraft with no electrical system, no transponder, or aircraft with an inoperative transponder. No TCAS display symbols, advisories, or guidance are provided to avoid aircraft without an operating transponder.
ICAS above the EPR gauge. The total air temperature is displayed on ICAS above the EPR gauges. The thrust management computer or the air data computer is the source of this data. These values are derived from the ADC and are displayed on the progress page 2.
Three inertial reference units. The 767 Inertial Reference System, IRS, includes 3 inertial reference units, IRUs. All IRUs are controlled from the same IRS control panel. The principal output of the IRUs is attitude and heading, both true and magnetic. In addition, the IRUs provide track, ground speed, wind speed and direction, vertical and lateral acceleration, and present position in latitude and longitude. All of these items, with the exception of acceleration, can be read on the 2 IRS displays. When a line is illuminated, steady, the related IRU is in the align mode, the initial attitude mode, or the shutdown phase. Flashing, alignment cannot be completed because of a significant difference between previous and entered position, or an unreasonable present position entry, or the present position entry is still lacking, or the aircraft has been moved during the align process. When a line is extinguished, with the IRU mode selector in navigation, alignment is complete. IRU is not in the align mode. With the mode selector set to attitude while in flight, the align light extinguishes after 30 seconds to allow for the system to sense local level required for level flight. When on DC is illuminated, normal AC power for the IRU has failed and the unit is now using hot battery bus power. On the ground, if AC power fails, a horn sounds in the nose wheel well. An ICAS advisory message of left, center, or right IRS on DC is displayed. Note: on DC normally illuminates for a few seconds during the alignment self-test. When DC fail is illuminated, DC backup power for the IRU has failed. ICAS advisory message of left, center, or right IRS DC fail is displayed. When fault is illuminated, the system has detected a fault. An ICAS advisory of left, center, or right IRS fault is displayed. Three individual mode selectors are used to control the operating modes of the IRUs. Each selector must be pulled out to move it out of the navigation position. The keyboard can be used on the ground to enter the airplane's position in latitude and longitude for IRU alignment, although position data is normally entered on the FMC CDU, to be described later. The IRUs must be aligned before they can enter the navigation mode. The airplane must be on the ground and remain stationary during the alignment. However, aircraft movement because of wind or loading does not prevent alignment. The alignment process is started with rotating the IRU mode selectors from off, through align, and to the navigation position. Each IRU goes through a 10-second self-test that illuminates the on DC light while the IRUs test the hot battery bus DC power source. The on DC lights extinguish as the IRUs start operating on their normal AC power source. The alignment process takes about 10 minutes while the IRUs calculate latitude and true heading. The IRUs provide magnetic heading by adding the present position's magnetic variation to the aircraft's true heading. Present position in terms of latitude and longitude must be entered during this time for the IRUs to complete the alignment process. The CDU position initialization page is normally used to enter the present position, which then becomes the starting point for FMC navigation. Present position entry can also be made from the IRS panel by pushing the N, number 2 key, or the S, number 8 key for north or south latitude, then continuing with the insertion of the latitude numbers. The latitude is then entered using the Enter key, which enters the data from the display into all 3 IRUs simultaneously. The longitude is then entered similarly. With present position entered, the system automatically enters the navigation mode at the completion of the alignment as the align lights extinguish. High latitudes between 70 degrees and 78 degrees require an extended alignment period. The IRU mode selectors are positioned to align instead of navigation and are allowed to remain there for a minimum of 17 minutes. The present position is entered during this time. After this extended alignment period, the selectors are rotated to navigation. This method may be used to quickly realign the IRUs without going through a complete shutdown of the IRS and going through a regular alignment process. The aircraft has to be stationary. Fast alignment is accomplished by selecting Align, which generates set IRS position boxes, entering present position, and repositioning the selectors to navigation. Fast alignment removes accumulated errors in track, ground speed, and attitude, and updates the present position. The process takes only 30 seconds to complete. However, if the time from the last full alignment to the completion of the next flight segment exceeds 18 hours, a full alignment is required. Normally, the IRUs operate on AC power. The left IRU receiving power from the left AC transfer bus, the center IRU from the center AC bus, and the right IRU from the right AC. The hot battery bus is used as an alternate power source. An illuminated on DC light on the IRS panel indicates the normal AC power for the related IRS has failed and is operating on DC backup power from the hot battery bus. A ground call horn sounds in the nose wheel well if the aircraft is on the ground and normal AC power is lost, providing an alert to the flight and ground crew that a battery drain condition exists. The illuminated DC fail light indicates DC backup power for the related IRS has failed. If the other lights on the IRS panel are extinguished, the IRS operates normally on AC power. Shown here is the condition of the electrical system when the battery switch is selected off, cutting off DC backup power to the IRS. The right IRU can only operate for a limited time on DC power. In case of a right AC bus failure, the right IRU operates on DC power for only 5 minutes. At the end of 5 minutes, DC power is removed and the right IRU shuts down. If an IRU loses both AC and DC electrical power, its alignment is lost. Alignment can also be lost if the selector is moved out of the navigation position. The navigation mode is rendered inoperative as of that moment. Therefore, heading and attitude information are immediately lost. However, selecting the attitude position and flying level for 30 seconds can reestablish the ADI attitude display. Additionally, HSI heading information can be regained by entering magnetic heading through the IRS panel or the position initialization page of the CDU. Other than attitude and heading data, the IRU is not able to provide other functions when operating in the attitude mode. Full navigation and position information is not available until the aircraft is on the ground and the IRU has been aligned.
Unit. Flight operating data and systems information is recorded on a permanent record tape in the flight recorder unit. The flight data is automatically recorded on the ground when an engine is operating, or in flight anytime electrical power is available.
A 3-position switch and an off light are installed on the accessory panel. The off light illuminates due to a loss of power on the recorder, an electric malfunction of the recorder, or a loss of input data to the recorder. The switch on position causes continuous recorder operation and is not normally selected. The momentary test position will activate the recorder during the recorder test. Now, during this time, the recorder's off light should extinguish. The switch is usually in a normal position. On the ground, with normal electrical power, the recorder operates during start of either engine. In flight, the recorder operates anytime it's powered, regardless of engine operation.
D is a new technology. The Integrated Standby Flight Display, ISFD, is a new technology instrument that replaces the standby instruments on earlier aircraft. More information is displayed on the ISFD, and the information is displayed in a format that is similar to the display of the PFD. The ambient light sensor highlighted on this frame automatically adjusts the brightness of the display for ambient lighting conditions. These switches adjust the brightness of the display. The plus button will increase the brightness, while the minus button reduces the brightness. The airspeed tape indicates current airspeed when above 30 knots. The attitude display on the ISFD provides the pilot with pitch and bank information. The aircraft symbol indicates aircraft attitude with reference to the horizon. The bank scale provides indications at 10, 20, 30, 45, and 60 degrees of bank. The pitch scale provides indications every 2.5 degrees. Beyond 30 degrees of pitch, large V-shaped arrowheads display in the direction back to the horizon line. The attitude reset button is used to reset the ISFD. Press the button and hold for at least 2 seconds to align the horizon with the aircraft symbol. The align process takes approximately 10 seconds and 10S is displayed. The reset button will also start a new initialization sequence while on the ground if the previous attempt failed. If the approach button is pressed when approach is not displayed in the upper annunciator, the approach mode will be selected. If approach is displayed when the button is pressed, the back course mode will be selected. If the back course mode is selected and the pilot once again presses the approach button, the annunciator will blank. The approach mode annunciation corresponds to the selection of the approach button. When it displays approach, the localizer and glide slope information is displayed. When the annunciation displays back course, it will reverse the localizer sensing so that the back course presentation will appear normal. These displays show the localizer and glide slope information to the pilot during a localizer or ILS approach. The localizer scale is in view when either the approach or back course mode is selected. The glide slope scale is in view when the approach mode is selected, but the pointer and scale are removed when the back course mode is selected. These scales represent the aircraft heading and altitude. Pressing the hectopascal inch switch changes the altimeter units of barometric reference from hectopascals to inches and vice versa. The barometric setting is displayed as shown. The barometric selector allows the pilots to change the barometric setting. If the pilot pushes the selector, the standard barometric setting is active. If the selector is pressed while standard is displayed, the previous barometric setting is selected.